energy, space, and cost in running a data center? Not to worry. A new green age is closer than you think. It's coming. It arrived. Start reimagining data center sustainability and cooling. Get ready to discover the future of data centers with us. Last but not the least, another star-studded panel discussion is coming right up. Let's hear from the experts on the panel discussion why the modern data center must be green. We are thrilled and privileged to host Mr. Prashant Kumar Roy, Senior Director FTI Consulting, Washington, D.C. as our moderator, Speaker Sachin Valla, Vice President, Schneider Electric Secure Power Division, India and SARC, Shailesh Tyagi, Partner Climate Change and Sustainability Services, EVA India, and Irina Ghosh, Executive Director, Cloud Solutions, Microsoft India, and finally Alka Astana, CTO, Indus Towers Limited. Without making a further delay, over to you, Mr. Prashanto.
Thanks very much, Manjeet. Delighted to be on this panel, which is, I think, a very key area with this explosion of data services, data centers, and driven by newer cutting-edge areas such as cryptocurrency mining, which half the youth I know of are interested in, if not able to actively do it. So clearly, we are at a situation where data centers are consuming a significant part of the world's power. Estimates are anywhere between 1% and 3%, depending on where you look, and rising. That's a huge challenge, not just for the global energy situation and consumption, and that's also one of the reasons cryptocurrency is actually frowned upon. It's very, very energy intensive, but we are not talking crypto here so much as the data center itself. But beyond that, for India itself, a particular challenge in terms of energy, the fact that our utility, the grids are typically not as reliable. So you have to have at least two levels of long-term reliable backup, increasing your costs and so on. So, we've clearly seen a situation where high-performance computing has been really growing exponentially. So you're trading energy consumption for, increased performance. Your power density per rack in data centers has been growing kind of rapidly. People are looking, for a long time, of course, renewable energy has been an alternative. And in the last, I think, 2 to 3 years in India, we've seen quite an explosive growth in solar photovoltaic panel installation for at least, buildings, homes, government buildings, schools, all kinds of things. And to an extent in data centers. I think we have in this panel, we have quite an interesting mix. So we will be able to hear not just about the data centers, but the one other major area of energy consumption and backup requirements, which is the mobile towers, which is another area which is really affected by India's lack of kind of reliable power across most of it. So you have to plan on actually backup at two levels. You have UPS backup and you have DG set backup. So I'll jump quickly to the panel. We have a short time with us of about 40 minutes or so. And I'm going to ask in alphabetical order the panelists to just come up with a quick overview of a maximum of 3 minutes. What we are trying to do here is identify the issues, challenges, look at the opportunities. And also we've been asked if we can suggest any inputs that may be required into the curricula for the IITs and perhaps for other engineering institutions in this whole context of data centers. So with that, can I ask Alka to, and I think we were all introduced, but you could still start with one line of background. Go ahead, Alka, your 3 minutes.
Sure, thanks, and glad to be here. I'm Alka Astana, and I am the CTO for Indus Towers Limited. What Indus Towers does is to provide infrastructure to the mobile operators on a shared basis. And the sharing part is so very significant because that also adds to a little bit more of sustainability and greenness, because if you were to put up individual resources for everybody, you are consuming that much more energy besides other resources. So sharing in itself is a step towards being greener, a step towards being more sustainable and being less wasteful. Having said that, what is happening now in telecom space is that we have seen a surge of data usage. And I come from telecom background, so I kind of, bring back a lot of telecom related perspective. Of course, I'm aware that data centers to a large extent have been in the IT domain. But what happens is that with the coming of 5G, to some extent even 4G right now, a lot of coherence is there between the telecom world and the IT world. So, and especially after COVID, data has suddenly just blossomed. The data usage has blossomed. The need for data coverage has really, increased by leaps and bounds. So what that means is that we go further down, closer to the customer, closer to the user. And what that essentially, again, drives is multiplicity of data centers. We call them edge data centers in telecom parlance. This is separate from the data centers which you have typically been used to. So there's a new breed of data centers which are coming up. Needless to say, it is all a 24/7/365 kind of operation. When we talk of such kind of reliability, high reliability, 99.99 uptime kind of thing, a lot of backup is required for the power. And when you talk of power backup, you can't only be on the EB, on the electricity board supply. It has to be, it has to have a storage, it has to have other power sources. Now, when we talk of power sources, yes, there is a case for solar, which would make it green, or wind or other sources, fuel cell and biodiesel and stuff. But with the kind of spread out of geographies, with the kind of small site size, small load size which we cater to in telecom, it suddenly becomes less viable, less easy to operate and maintain. Solar panels, for example, they get dirty by bird droppings, they get overshadowed by trees and so on. So operations becomes a very big challenge. None of us can tolerate even a small blip in the telecom network, right? So that kind of a maintenance is very, very essential to how we operate. And when that comes into the picture, green suddenly becomes more difficult, not less. Technology kept aside, technology has been, of course, growing, and there are more opportunities, more options available now. But how we kind of make use of it, how we adopt it, is a larger function of so many other factors, including what is the cost point, including what kind of maintenance is required, whether it's a fill it, shut it and forget it kind of thing, or you have to send people repeatedly. Right? So those are the kind of issues we are kind of handling step by step. We do have a lot of solar deployments in distributed deployments, actually, because also the regulation does not allow us to have one single point of solar generation and then use it or offset it against our distributed load. So those kind of things can also come in from the government in order to make it more viable commercially as well as practically. But there are aspects that have to be kind of stitched together before the further journey can be made. So long the importance is there, the priority is there. Right. So, and I'm very happy to be part of this panel and listen to some newer ideas which could just make the needle move. So over to you back. Thank you, Prashant.
Thanks very much, Alka. Quite a few points you raised, and I would love to ask you more about some of them, including, how we are going in terms of low power equipment, where you get to power levels which are low enough for you to be able to skip DG set backup and, stick to UPS kind of backup. But I'll come back to you on that. Irina, your 3 minutes.
Sure. Thanks a lot. And indeed a pleasure. And welcome everybody to this panel conversation. I lead the cloud business for Microsoft India. So what I think we need to have a pertinent and relevance to is that we see Azure and all the hyperscale platforms as they're coming. They bring in a lot of relevance and questions towards the area of, say, sustainability and what would be humanity's response to climate change. So together, it's the need to create that cleaner, greener future. And what we've done is now we've put in sustainable technologies at the heart of every innovation that we do. So which means that everything that we are developing, everything that we are kind of integrating with our partner ecosystem, this forms a core pillar and a pivot. And towards this, we also make some sustainability commitment to ensure that the goals are real and what are we pledging against. And we've chosen some of those really impactful areas, which include things like the carbon, ecosystems, water, and waste. And what can we do around these? So some of the things that we've really pledged are going carbon negative by 2030, going water positive by 2030, zero waste by 2030, building a planetary computer ecosystem. And we've also put in a pledge saying that by 2050, whatever has been the carbon emission that we've put in place ever since we've been founded, how can we get that annulled and taken across? The bigger part of this is how are we taking measured experiments right now to see how we create this for the future. And towards this, one of the things that we did was an experiment called Project Natic, in terms of seeing that how can we have, say, subsea data centers powered by offshore renewable energy. And I'd like to talk about that during the course of the discussion as well, because that goes into showing that alongside a experiment and a controlled group environment, what can be built across for the future in a very sustainable manner. So that's an experiment that we did. The second is, how are we making it real for ourselves and working alongside this with our customers as well? So we've created something called the Microsoft Cloud for Sustainability. Now, the entire intent of this is to ensure that we measure, we put across goals, we monitor, and then we either reduce, replace, or have a correction mechanism in place by leveraging technology at the best. So basically, what should be the role of the CIOs? What should be the role of the operations team? What should be the role of the entire ecosystem? And how can we gradually get this in place? So in summary, the two things that I really kind of want to delve into would be, how are we getting ready for it today? And how will we work across with the rest of the ecosystem towards ensuring that we have a sustainable future? Back to you, Prashanta.
Thanks, Arina. That's very helpful. And again, quite a few points you raise, which I will come back to, including on the interesting cooling related experiments. Power, of the whole data center, I understand about half of the energy actually goes in power related and cooling related equipment and areas, and the other half is actually just servers and storage and so on. So if you can actually cut down that cooling requirement, you end up saving a tremendous amount of power. But we'll come back to this. Sachin, your turn.
Thank you, Prashanto, and thank you, Alka and Irina, to give your perspective. So I am Sachin, and I lead the Secure Power business in Schneider. So Secure Power basically supplies the cooling equipment, the UPS, and we are also responsible for selling all products of Schneider to data center. So we front end the entire Schneider portfolio for data center customers. And when I look at Schneider portfolio, we make all the equipment which are required to take the power from the grid to the server. So whether it is electrical distribution in the middle, whether it is bus bars, whether it is transformers, whether it's UPS, we make them all, and we also make the cooling equipment. So as Prashanto was explaining, I think 50% of power consumption in the data center goes through our equipment, and that's why we have a bigger responsibility, or a big responsibility, to make sure we make the data centers more efficient. And I think the importance of sustainability or green or efficiency is very high in data centers because of the level of power consumption that happens there. For example, if we can shave off 1% in efficiency, that will result into 7 to 8% lower operating cost. Okay, that's the level that's the level of benefit we can deliver if we can have equipment which can deliver, or which can improve efficiency by 1%. And what I would tell you is the way we look at this whole sustainability, efficiency for data center in 3 ways. One, how do we source sustainable power? We actually have a unit which helps data center companies on saying, how do you source power from renewable players? What's the best way? How you can reduce your cost as at the same time source power from more responsible companies and more responsible sources. Second, we focus on how do we deliver products and solutions which are electrical solutions which take power from gate to server. How do we deliver such products and solutions where the efficiency, when right now the norm in the industry is you lose around 10% power when you go from grid to a server point. But we have achieved technological improvements in different equipment, and we are able to deliver power by saving around 4% from that 10% and only consume 6%. Now I'll tell you, we have UPSs, while the industry average is around 97% efficiency, 96.5% efficiency. We have UPS which can deliver 99% efficiency. Right? So that's the kind of work that the company is doing to make sure that we are able to do a better job of green and deliver high efficiency systems within data center. I think what is also important is these are one-time systems that are installed. What is important is how do we optimize the systems again and again, because as data center is also evolving in their power needs. So that's the third angle we look at. How do we install different sensors which are controlled by software systems, which can optimize the cooling requirements, for example, which can optimize, okay, how much is the power going? What is the power consumption at various point level? Do we need to switch off something? Are there opportunities to save? So we are trying to build a work in 3 dimensions: source power responsibly or from sustainable sources, then deliver equipment to data centers which help them reduce their energy cost by 30-40%, and not by 1 or 2%, but 30-40% reduction in their operating cost. And then even after you have done one-time installs, how we can use software and sensors to continuously optimize their electrical power load and help companies or help data centers to reduce their costs. So very excited to be part of this group. I am from IIT Delhi, so very excited to be part of PanIIT. Thank you for inviting me.
Thanks very much, Sachin. Shailesh, over to you.
Thank you. Thanks so much. Look, I think we have heard everything, right? So I need to now be careful that I don't repeat. But as a quick intro, I'm a partner in the climate change and sustainability practice at EY. Recently come back to India 6 months ago. Most of my experience has been in Australia and New Zealand. Specialized driving ESG services here, along with the CCAS lead partner. So look, that's enough about me. Let's hear. I'll share. I put in some slides. I got a lot of flake for putting these slides, but I think I only work better when I have something in front of me to talk about. So I'll share my screen and all right, cool. And Prashant, I'll ensure that I finish in 3 minutes. My timer is on. So in terms of the data center, let's take a step back and let's look at the whole world of ESG, right? We are everywhere we go, everyone talks about environment, social, and underlying decision making. So what it is it any different to sustainability of a data center? Honestly, if I have to sum up ESG, it's all about every company, every installation, every project should have a process in place to identify their material environmental aspects. Environment, think about natural capital, right? Natural resources, environment, waste, water, greenhouse gas emission, pollution. Think about relationships, every single relationship, operational, upstream, downstream, customers, suppliers, cyber and data privacy. Think about safety and the underlying decision making around that, right? Social governance, sustainability governance, climate governance. Who is driving it, right? Regulators are driving it. There's a lot of push from investors, and of course, the Gen Zs and Y. I don't even say millennials anymore, So moving on, in terms of when we look at data center, what are some of the parameters? Let's look at it from the lens of holistic assessment. What are some of the guidelines, some of the standards? So I'm doing a lot of work in this space, or I've done a lot of work in this space. And if we start looking at the aspects, of course, we talk about energy consumption, energy mix, greenhouse gas emission. We talk about various efficiencies, common terms. But then how we link that to waste and water. But then in terms of how you also improve your social performance, your underlying governance performance, very important. So you have to look at it holistically. That's what every stakeholder is expecting. It's just not about carbon, or I would say energy and carbon, right? Or water. You have to look at it holistically. Science-based target initiative, how you really look at this in terms of, say, science-based targets. Sorry, I moved the slide. So how you look at it from the lens of science-based targets. What is data center contribution to overall emissions? So you can't lose sight of that, and how the trend should be if we have to align ourselves to 1.5 degree global warming, right? And then it comes down to, of course, various standards, right? Real estate, of course, that will be applicable. So we have GRESB, right? Carbon Disclosure Project comes down to looking at your emission numbers, scope 1, scope 2, scope 3, but also around climate risks, which links to Task Force on Climate-Related Financial Disclosure. And of course, the mother of reporting in extra financial, non-financial would be GRI. And there are a couple of other standards like SASB and all. In terms of final slide, in terms of investor push, look, there's a real investor push coming out of UNPRI, Principles of Responsible Investment. All these major asset owners are driving it. I always say Larry Fink every year sends a letter. Last year was about ESG, this year is about TCFD, which is climate risk, and a lot around SASB, sector specific. So just to wrap up, look, a lot happening in this space. And if you want to bucket it, it's about energy efficiency. It's about clean energy, because energy transition is happening. So outside in view, I'm not talking about inside out view, water and circular economy. So these are some of the aspects. Over to you, Prasad. Thank you.
Thanks very much, Shailesh. I think that was a great overview. The slides probably helped put quite a few data points in perspective. So let me quickly get, in the 20 minutes that we have, just raise a few of the points. So clearly we've seen power is very critical in terms of a whole lot of things, not just higher ambient temperatures, so all of that together, and probably not that much of a room for reusing waste heat. In the West, we've got examples of using it to heat swimming pools in the community, etc. You may not have those same use cases here. So I will just put this question to you, that in terms of technology, and keeping in mind we are also being asked to give some inputs for areas that engineering institute should look at in terms of curriculum. In terms of technology, where are we headed? What is happening on the low power side? I mean, clearly take processors, hard disks, movement to SSDs and all of that. So they've all moved toward lower power, but equally, the performance demands and the power densities have been rising, and maybe because the overall performance demand has gone exponentially, and it's not been able to keep up. Similarly, on the mobile tower side, how are we doing in terms of the low power BTS units and so on, so that you can, in many cases, maybe look at skipping the second level of backup, provided you don't have outages which are more than whatever, an hour or 2 hours or something like that. So your 12-24 volt DC UPS can actually take care of it. So this is a question to the panel. What would you highlight as promising areas of technology development which are happening, and which are the real problematic areas still, which would help us jump forward in terms of better power utilization and energy saving? Anybody? Alka, do you want to go first on the BTS units and the mobile towers part of it?
Yes, please allow me to. And just 2-3 points. One is that yes, the load requirements per se have been coming down because of primarily the development in the electronics per se. So lower power required to kind of reach out. But on the other hand, what is also happening is that just because the users have increased, the data speeds have increased, the complexity of the network has increased, and the delivery of services is also pretty complex. What happens is that you have to throw that much more power out. You cannot have low range kind of things deliver that kind of a coverage, and most of it is now going indoors. So that can't cross the walls and stuff like that. So there is a management of power which keeps happening. So the load sometimes increases. For example, we have massive MIMOs, and when you talk of massive, the size is not just physical; it is also the consumption of power. Right? So those are the things which are also adding to the power requirement. What had also happened in favor is that most of the mobile capacity turned outdoors from indoors. It used to be indoors earlier, and the air conditioning requirement was huge. But now the air conditioning has actually reduced to a large extent because everything is outdoors, and they are independent boxes which stand out, on the ground, open to the environment. There is not a dedicated air conditioning which is required. So you see fewer and fewer shelters, for instance. Those are the positives, but again, there are dust elements. There is humidity element again, which causes a little bit of challenge. So you try to enclose it in a box, and then the temperature goes up. So you have to provide cooling, and that again guzzles some power. So it's a it's a mix bag where some steps are forward, some steps are backward. Not because technology is not supporting, but also because the use or the range of services has just exploded. The data usage has exploded. As far as the backup part is concerned, and you're right that ideally we should not require backup totally, right? The EV has to be so reliable that it just becomes seamless. But the fact is it is not. And it's not reliable to the extent that you don't know, at least we don't know while in operations, that it's going to be off for, let's say, 3 hours. Then I can cater to 3 hours, right? With a larger storage or something like that. But it is, sometimes 3, it could sometimes be a long outage. So you have to prepare for, the worst case scenario. You can't really be sitting there that, okay, whatever is the best case scenario is catered to, right? So the dimensioning has to be that much more accurate. So it falls to and of course the last resort is to have diesel there, but that's the last resort. We do not prefer it. By any stretch of imagination, it's the last resort, but it is required because it's the basic need. You cannot have mobile network going off because there was no power, right? So those are the things which are up and down. The hydrogen fuel cell, etc., is coming up. Again, the supply chain is a constant challenge. If it gets so widespread, yes, it will become far better. Right now, it isn't. It is at that threshold where even lithium-ion, for that matter, for the mobile industry, is not so widespread as it is for maybe vehicular automobile industry, right? So there are challenges. Lithium-ion does not get, let's say, produced in India. It's again an imported item. The cost points become a challenge, so on and so forth. So there are balancing acts which are going on. Technology is helping, but there's much more which requires to be done.
Okay, so that's an interesting point. The supply chain issues are also a determinant of what would really work in India. And if you suddenly have issues with, let's say, China and the supply chain, then lithium-ion itself becomes an issue. For the others, Irina, Shailesh, Sachin, in terms of technologies which you see promising on the electronic side, shift to lower power, shift to SSDs. On the backup side, what are some of the promising secondary backup technologies? Anybody?
Yes, so I can go next. I think there are 3 areas we have to focus, or if the institutes have to focus. I think the first area is software. Okay, because what we are seeing is the next level of innovation is coming. There are a large number of sensors are deployed in the data center, whether it's at data centers, or a large hyperscale data centers. And what we are seeing, at least, and we see our competition is also moving in that direction, is how do we get a lot more data, and then we are working on how do we use that data to create some meaningful insights on how to optimize. So I think what would be good for the institutes is to look at how do they teach students about what kind of sensors are available, using that, what kind of data can be picked up, and how you can analyze those data to create meaningful insights, which I mean, in a way, it's AI and machine language. That's the thought process, but that is going to lead the innovation because it allows you to feed in multiple data points and then take decisions. So that's one area. Second area I would say is that we are seeing a strong movement towards lithium ion. I would say that in large data centers, we are seeing massive deployment of lithium ion. Yes, we are seeing shortages of lithium ion as well globally. At the same time, we are seeing the companies ramping up supplies very, very fast. We actually have now 2-3 different vendors who are supplying us lithium ion batteries, and we are seeing in the next 3 to 6 months supplies getting more streamlined with multiple vendors supplying to us. The price points are coming very, very attractive. So my viewpoint is that we will see a lot more propagation of lithium ion batteries. And at some point of time, as the prices continue to reduce, the use case of using lithium ion batteries everywhere will become more and more stronger. And my advice again on that area would be there's a lot of work being done by companies in the area of BMS for lithium ion. And as more use cases will come up, there would be need for more and more engineers who can work on defining or creating these battery management systems. Because for every specific use case, you need to tweak that battery management system or recreate the battery management system. So that's one area. And I think third area is on renewable side, on sourcing side. Again, that can be one area because solar is also growing. So what can be done on that area? And that's also quite a vast area because we will see solar cells being manufactured in India. A lot of companies have announced, government has announced a lot of schemes. So we will see solar as one big area. So that would be another interesting thing to focus on for companies on creation of solar solution. How do you increase efficiency? How you can implement the plant? To how the whole PPA process works. How can you do energy consulting? Another area could be, can you teach students how to figure out to do energy audits and figure out what are the ways to optimize, because it's a large setup. I mean, in a data center, we're talking about large data center. At times, we're talking about 30 megawatts, 40 megawatts being consumed in a couple of buildings. If that is the case, can we build capabilities in our students to go there, enter as an energy consultant, and do the audit and figure out here is where areas of improvements are. So I see these are some of the areas which will grow faster in future, and in some areas where institutes can focus.
Terrific. So a lot of sensors, analytics, IoT, data. So that's a massive area to actually look at, and even from the context of engineering institutes. Irina, would you like to go next?
Yeah, I think I'd like to pick up the thing on the part about renewable energy, and your question was what can be done by academia. I would also say that this entire concept of putting this underwater data center experiment actually came in one of our what we call a Think Week, in which employees are really encouraged to come out and talk about out of the box thinking ideas. So this was brought across as a concept by employees. And actually, in just 12 months after launching this project, the Project Natwick team, they built the proof of concept, the prototype in the shallow waters of California. And what really happened as a part of that when it came across to showcasing this in the COVID-19 research for a home and world community grid project, that really took effort. Now, the good part about this is that the fact that while the rest of the data and all the sensors are still getting kind of analyzed, some of the things which have already come out is that the pressure vessel, heat exchangers, servers, everything can be recycled. The second thing that we also realized was the failure rate for this experiment was about 1/8 of the land-based control group. The fact that the subsea data centers can be powered by offshore renewable energy, yes, it can be done. So these are things which were really proven. And the other part was that focusing on renewable energy, whether you do it from the solar, the turbines, or whatever you're doing around the submarine ones, these were really new concepts which are getting experimented in the concept of data centers. So drawing the real analogies became very, very critical. I would say these are great areas to kind of experiment and research in context of working for the corporates along with the academia too.
That's terrific. So the subsea part of it, is it the heat exchanger which is subsea, or is it the whole data center?
The data center.
Okay. One would have thought that you could have done with the heat exchanger part of it and leave the data center more accessible.
Sure. So it's a longer research which has been done. So there are lots of findings. There's a phase 1, there's a phase 2 also, which is kind of coming by. So happy to talk about it later.
Shailesh, and let me also bring up this question to you, that in terms of India, and we've seen that when we take web space, etc., the Indian options have typically been higher, and we hear that costs are higher. Do you have any sense of what is the kind of differential due to this set of factors that we've spoken about, which makes it a little more expensive in India? And what are some of the promising technologies and directions to address that?
No, it's you can hear me all right, Prashant? Yeah. Okay. So, look, when we start looking at India, I guess it's more. There's a lot to learn in terms of a lot happening in Europe, right? So I would like to answer this under, for example, let's look at the sector. Let's look at the sector-specific ESG driver. The Climate Neutral Data Center Pact, right? We have NTT, Google, Intel, IBM, Data Center United, Equinix. They all are signatories to this initiative, and it all is coming up from if you start looking at the data center operators and trade association, they're coming together to the whole as part of the commitment under European Green Deal. And what it is, it's ambitious greenhouse gas emission reduction. The climate law, I call it, right? Climate emergency, as they say there. And they want to leverage technology. They want to look at digitalization. Some of it we have covered. There's a lot happening there already. All these companies I mentioned and a lot more, they have this goal of making Europe climate neutral by 2050. So from that lens, if you start looking at to achieve this objective, the data center operators, they have decided, look, we need to agree on self-regulatory initiatives. And what are they? So by 2030, they said, okay, we need to go climate neutral, right? Big ask. And for that, some of the pillars I covered, but if you start looking at energy efficiency, by January 1, 2025, all the new data centers there, greater than 50 kilowatt, operating at full capacity in cool climates will meet the annual PUE target of 1.3 and 1.4. And that's one. All right. And then if you start looking at those operating at full capacity in the warm climates, they have their targets as well. So there's a lot we can learn. The other thing is, if you start looking at existing data centers, they will achieve the same targets by January 1, 2030. So what are they doing? Some of it, of course, we have covered the challenges in India, but there's a lot to learn from it. The second, you can't just look at energy efficiency. You need to look at holistically the clean energy. So there, the data center electricity demand, they have decided that in Europe, they're going to match it by 75% RE, renewable energy, or hourly carbon-free energy. And the date is December 31st, 2025, right? And by 2030, end of 2030, they want to go 100%. So then you start looking at circular energy or circular economy or water. Similar initiatives, lot to learn, and for circular economy, the data center there, they have set up high bar for circular economy practices, and they decided they're going to assess, reuse, repair, recycle 100% of their used server equipment, right? So look, these are some of the initiatives, and we need to look at it holistically. The same with water, water uses effectiveness, WE, how they are looking at it, what their annual target. The first target is 2022, and then the next target for new data center is 2025, existing is 2030. So there's a lot to learn from what they are doing under this climate neutral data center pact for companies here, and then what we are seeing other things is and not losing sight of the whole ESG, as I always say. The benefits, I mean, always say, I'll answer your question more from the investor side, like ranking agencies like S&P Global, Morgan Stanley Composite Index, or other global benchmarking platforms. They are looking at the data center efficiency of the key parameters of assessment when they rate companies, right? So for their ESG performance, and that leads to cost of debt, raising capital, equity, and all. So yeah, so a lot happening in that space. Yeah, over to you, Prasad. Yeah,
I think we are kind of nearly come to a close. So what I will do is, if anybody has any last comment in terms of the path forward and the technology forward, I'd just like to mention a couple of things which we didn't have time to bring up. The one is on the heat exchangers front, just like waste heat utilization. There are processes, industrial processes, which generate basically waste cold processes, which are deeply endothermic, and liquid natural gas gasification is one of them, where you potentially have the ability to use that waste cold, as it were, with a heat exchanger, and if you have a data center in the proximity or something. The other big thing from the government side has been a big push on hydrogen and hydrogen fuel cell based storage. So renewable energy has a lot of erratic behavior, so you need to really level it out by storing it en masse. And lithium ion is an option, and Tesla has been doing some mega scale, citywide scale experiments, but it's not really sustainable to go forward and have our cities full of mega lithium ion battery packs. So hydrogen is one example of that. So with that, I'll just leave a last 30 seconds each, if anybody has a thought on what you find most promising in terms of the way forward in making data centers more efficient, especially in India. Anybody, I'll just let you go, whoever wants to go first.
See, what I would say, I already talked about what is happening from institute perspective. I think this is a good area to focus on, is what I would like to stress on. Given the rise in the demand for data and the number of data centers that are being set up, so right area to focus on, absolutely, please do focus on.
Terrific. Anyone else?
Say that maybe it's a good thing to just focus on three imperatives: the emission which is happening by what you're producing yourself, the emission that you're producing by something that you're kind of going in for, and with everything else in the ecosystem. A scorecard against that will really keep us honest on that.
Absolutely. I think that's a terrific point too, because a lot of times, I mean, for instance, we're using electric vehicles, but the power is usually from coal-fired plants. So your entire ecosystem wide, if you look, it's pretty crazy. Alka, Shailesh, from you, last words.
I think the key takeaways, as I said, would be you mentioned I would call carbon free and renewable sources, right? And how you can increase the efficiency in data centers. You mentioned hydrogen. Of course, hydrogen fuel cells, as per International Energy Agency, will play a key role, and they need to be looked into. I have my thoughts on it, but maybe for some other day. And finally, we need to look at bare minimum what companies are already doing. They're looking at hot, cold, aisle treatment, biophilic building designs, maintaining ambient temperature certain level. So that way, if companies can look at what's easy to do, what's the next step, like take baby steps, and of course, as all AI and machine learning is already covered. So yeah, those are some of the things.
Terrific. Thank Alka. Last word to you.
I would really, like everything to come together. There are individual silos which are working very well, but coming together is more important, so that the needle actually moves for everybody around, because climate, if it gets impacted, is impacting everybody around us, right? So the efforts in the right direction also have to be coming out together. That's most important. And I think the academics can really put a overall thread to it right from the very beginning of how we think about things and how we build solutions around them.
Terrific. I think that's a great note to end this on. We've covered a fair bit of ground. We hope we have given in some inputs and ideas for institutes to also consider key areas, ranging from power, equipment, backup, renewable energy, data, IoT, So that's a fair wide canvas to look at. So thank you very much. Thank you, Alka, Irina, Sachin, Shailesh, and it's back to the organizers.
Thank you, Prashanto.
Thanks, everyone. Thanks, Prasanto. Cheers. Bye. Bye.
Yes.
Thank you all once again for enthralling the session and transforming us to a sustainable, carbon-free, green data-centric future. It's our sheer pleasure and privilege to have you all with us today. Thank you very much.
Thanks, Manjeet. Thanks, everyone. Bye-bye.